we have a couple of people registered. Not all are there already. Maybe they joined later. We don't want to waste your times. You are on time, so thank you very much for this. Today, we have a special guest here. Before we introduce Tibor, we do some little housekeeping notes here. We have a recording, so if you don't want to be recorded, please leave and watch the session later. You're all muted. I think with the small group, we can do this pretty much interactively. So just drop your question in the Q&A and we can answer it directly. And for the next events, there is on the expertslive.at is the conference scheduled already. I don't know the dates by heart. Maybe we can post it in the chat afterwards. And we're also planning the Q4 meeting, most likely in November. And the topic will also be posted on the social media. The guy down here, by the way, is Doug Fink. Sorry, I copied the templates and this was with with him. So this is nobody joining here. Okay, today we have Tibor here from Hungary. Tibor has written a logging module and he has pretty high expectations to logging. And we are thrilled to see what he did. And so thank you very much for joining us, Tibor. Welcome to our user group meeting. And the stage is yours.
Okay, thank you for the invitation. Let me share my screen. And please confirm if you can see that. Okay, I put together some slides, but of course this session will be mainly around doing some demos for you. But first of all, let's try. So the title of this session is how to write one of the best logging modules. Of course, it's a little bit of exaggeration, but I proposed this session to the PS Conference EU, and you know they require some very catchy titles so that the sessions will be selected. So this is why I selected this title. The real agenda is about the requirements that I put together against a logging module. I worked at different companies and they have never asked me to write a logging module, but because they wanted to have some logging, I was forced to develop something. And throughout those years, I received quite a lot of different requirements, so I put together, and through these 9 years, I put together this logging module, and I would like to share one of the technical challenges that I needed to solve. So first of all, let me introduce myself. I worked as a Microsoft certified trainer for a couple of years. During those years, at the end, I was a PowerShell MVP, but since I joined different companies and I was not working as a trainer, I didn't have time to do the activities for a PowerShell MVP title. But I still enjoy giving lectures and do trainings. So this is why I accept this kind of request to present anything about PowerShell. As you can see, I'm in different dedicated PowerShell related roles since 2011. So I have quite a lot of experience on that. I wrote a PowerShell book in Hungarian. I developed this module that includes logging, but not just logging, but config file management, which is another interesting area and where you can't really find any official Microsoft provided solution. How shall we store configuration data that is consumed by our scripts or modules. In that module, I also have a couple of functions related to property management. So we work with objects in PowerShell, and there are quite a lot of tasks that require more advanced capabilities as provided with the default modules in PowerShell. And I also have a function around dynamic parameters for our scripts, how we can use dynamic parameters easily. I completed a couple of large PowerShell projects as a freelancer. Majority of those projects were around fulfilling requests coming through different request management systems. So my examples in this session will be around those scenarios as well. You can reach me through my email if you want, and you can see my LinkedIn profile in this slide. And at the bottom of these slides, you can see my GitHub repository as well, where you can access these script tools. So feel free to reach out to me anytime with any challenging PowerShell issue that you have. I try to do my best to help. So first of all, let's see what makes logging good, in my opinion. First of all, it must be simple to use. I've come across a couple of logging modules. One of the best ones among them was Threads. So this PS framework created by Friedrich Weinmann. And this PS framework contains a very professional and very capable logging capability, but unfortunately, that is way too complex for my expectations. So even though it's very good and very performant, my goal, my requirement was to have a much simpler solution. Only few commands, few mandatory parameters for those commands, and it should be maintenance free. So no cleanup on the long run, no cleaning up of obsolete log files and so on. So everything should be automatic. The log entries, the log files should be easy to read. Of course, the log entries are displayed on the screen if we use it interactively. So on the screen, we will be able to see different colors for different log entry types. For the log file, the navigation is supported by certain automatic indentation of the messages. So we can differentiate which type of message coming from which source. One of the primary features or use case of logging is to help troubleshooting. So the log file should contain the log line numbers of the script and the context where the message is coming from which function, which module, which script. And the log file should also contain the parameters so that we will know where to start our troubleshooting. One of the missing features in the different logging solutions is logging the progress. So if there is a long iteration of items, processing a lot of items in our scripts, it would be nice to have some information how this is progressing. Of course, if we are using the script interactively, we can put up some progress bars, but if the script runs in the background, it would be nice to have some automatic log entries from time to time so that we can see how the script progressed in the past. Error handling. Of course, it would be nice to capture all types of errors, not just the ones that we are expecting, and we put some error handling around those code lines. But we should log also unexpected errors as well. At one of the projects I worked on, there was a requirement to support multiple log files at the same time for a given script. Because the company decided that they don't really want to see the boring entries. Boring entries means that most times a script set up some connection to different systems, read some database entries, connects to web services, and so on. And of course, we want to log those actions as well, because if there's an error, we should see that. But 99% of the times, these are successful. So there is no real reason to keep those entries on the long run. But there are also other type of log entries related to processing certain items, processing requested items, processing an Active Directory user, and so on. So these entries should be preserved on the long run, because those log entries serve some sort of tracking or auditing purposes as well. So there are different type of entries. So we should have a log file which contains this boring stuff that can be cleaned up after the execution of the script. If there is no special errors, we can just remove it. But the other type of entries should be preserved. Because we work with objects in PowerShell, we should be able to easily log objects as well into these log files. Of course, if there are a lot of objects, we probably don't want to export them into a log file, but we should rather have some special file for those objects in the form of a CSV or other forms. And the logging should also support these capabilities. And the last one is to be multi-platform, meaning that the same code should be run fine on a server, on a local machine. But if we want to run the very same script in Azure as a runbook, then the log entries should be compatible with the Azure runbook environment as well. And there should be no change needed in the script. So that was one of the last requirements I developed, I fulfilled during the development. So let's switch to the demo. And here's my script. This script is quite, the structure of the script is quite common. So the script has a parameter block. It has only a single parameter. It has a helper function. As you can see, I call it subfunction. And it has a sort of a body part, the main part of the script logic, where I start with importing the script tools, which contain the logging capabilities. And generally, we should have a single line of initialization. But in this demo script, I have multiple because I will simulate different scenarios. So this is why I have 4 different initializations, but generally we should have a single one. And I also import another module in this script. This is quite common as well, that you use some external modules as well. I have some variables, and I write my log entries several times in this script. Okay, so I don't really want to get into more detail about the script, but rather let's just run it. So this is the demo log. And the first scenario is a very basic one. In this scenario, I just want to see the basic features of the logging. Okay, so now you can see that here the log entries are also written to the screen. The same log entries are written to a file as well. And here you can see different columns. The first is the timestamp. The second is the line number of the source code where this log entry was generated from. So if you look at here, it says line 68. So if I scroll down to line 68, then you can see that all of these entries, quite a lot of entries at the beginning of the log file, are generated by this single line. During the initialization, I see a question. Go ahead.
Yeah, sorry to interrupt you. I have my first question.
Yeah.
You know, when because of the line number, if I have a module, let's say, which calls a function, which calls a subfunction, which line number are you actually referring to?
You will see that later.
Okay,
I will show you. I will show you. Okay, so this single statement, the initialization itself, will generate quite a lot of log entries. It populates a header for the log file containing quite a lot of information automatically. The only information that needs to be specified is the title. This is the logging demo. You can see it's the first line. But all the other ones are calculated automatically by the function. So what is the script name? What is the script path? What is the script version? Because if you look at it, I use this inline help at the top of the script, and it has a version information with a version number and a date, release date. And it's included, it's parsed and included in this header. It includes who is the script run by, whether it's an administrator or not, computer name, log path, log folder, and when the log started, and what is the environment. Here, the environment is the PowerShell ISE host, but of course, if I were using some other type of host, or I were using the Azure Runbook, you would see that as well. So this is the role of this environment. You also see a sort of a subheader containing the parameters that were used during the invocation. All of these are generated during the initialization. We are still at line 68. And I simulated some old obsolete log files in this folder, and all of these were cleaned up as part of the initialization of this new log file. You can see that the log file name includes the date and time stamp. Sorry, in this case, only the date stamp. And any log file with the same name pattern are automatically cleaned up during initialization. The default retention period is 60 days. But of course, if you want, you can override this default value. So if I click here, and you can see that I could specify quite a lot of parameters, but most of them have a default value. Here's a keep days parameter, and I could specify that the log entries, log files should be preserved for 1 year, as an example. Okay, so there are quite a lot of capabilities to override most of the default values. But for simplicity reasons, I designed this module to require only as few parameters as possible. Okay, we finished the line 68 here. And the next entry is coming from line 76. And here you are. This is a simple information type of entry, nothing fancy. in the next column, you can see the type of information. It's an info type. And the context you can see in the next column is the script itself. So we are at the highest scope during this log entry creation. So this is why the scope is demo log.ps1. If we go further, the next is from line 83. We are here. And I wanted to have a less important information to be entered to the log file, so I use an indentation, indent level 1. As you can see, it's really indented to the right a little bit, so we can separate information based on their importance as well, using indentation. The next one is I wanted to have the call stack, more precisely the first element of the call stack written to the log file. So I've created a format log string list function, which can output objects into a list view, similarly to format list. And then I am able to redirect that information to the log file and to the screen as well. We will talk about that a little bit later. Okay, the next one is a warning in line 90. And you can see the type is warning. The color is different. The entry type column, you can see that it's a warning. Here's an error one. This is an error. You can see the next is in red. I have another type of entry, and here is the answer to your question. I'm using the sub function. I'm invoking the sub function here in line 101. The sub function is defined within the same script. So you can see that the source code of this function is here, this sub function. And here, the entry is coming from line 11. And it's a highlight type of entry. It has a different color. And the context now says it's from the sub function. And it's automatically indented to the right. So you can differentiate between the highest scope from a child's scope of the script by this indentation. Of course, if you want, you can override the indentation. Here's an indented entry from the function in line 18. You can see it has 2 indentation to the right, but of course I can use an absolute 0 indent, so have the entry aligned to the left using indent level 0, and with the absolute indent switch I turned off the automatic indentation. Okay, what we have in the log file, here's an output generated by the script. It's not part of the log file. I don't know if you can see, but its color is the bright white, and the log entries are light gray colors, so that we can differentiate between the output from the log entries as well. Okay, and we are reaching line 104. It's another highlighted entry from the main script. And then we have again a couple of entries generated by a single statement in 189. So if I scroll down, this is the single entry that generates a couple of lines. So it's a normal exit from the script. it has a special type called exit. You can see here as well in the log file, it's an exit type. And if you have an exit type, nothing below that line will be executed. So I didn't need to put a special return statement or anything else, but this exit type of entry automatically exited the script. So this will never get executed. Write host statement will never execute. And in addition to that, you can see footer automatically inserted because of there's an exit statement. So log name is there, the runtime, how many errors, how many warnings were logged, and what was the parent process of the PowerShell host that executed this script. This is especially important if you are executing PowerShell scripts via SCCM or some other automation systems to know what's the parent process, because you may want to have exit codes to be injected to the parent processes in different ways depending on the parent process. Okay, the next one, next scenario.
Short question in between.
Yeah, sure.
Shall we do a short question round? This was a lot of information.
Yeah.
Any questions from you guys? Any ideas found already for your personal needs?
Okay, if no questions
yet, not, just continue.
Yeah. So in the first scenario, I used the verbose mode during initialization. You can see here I used the verbose switch. So everything that was written to the log file was also displayed on the screen. But of course, I don't need to do that. In the silent mode, majority of the entries were not exposed on the screen. Of course, they were written to the log file. There's one exception coming from line 83, where I used a local verbose switch. So that specific entry was written to the screen as well. If you want, you can do that. The next scenario is the unhandled errors. So here in line 98, I wanted to remove a file which does not exist. I didn't use the error action stop option. I didn't have try catch block. I didn't have any advanced error handling here. I just have this non-terminating error. Of course, because I'm using the script interactively, I can see this error popping up on the console. But you can imagine if I were running this in the background, I would not notice that there's an issue. But my logging automatically captured this unhandled error, and it was written to the log file. The way how I did this is actually, if you look at the line number 11, this error was not happening in line 11, but it was happening in line 98. But the next standard log entry was written by this specific statement. So every statement, every new log entry statement checks if there is any unhandled error, and if so, then it ejects those to the log file and to the screen. For this, I use the $error array. So at the beginning, during initialization, I clear this up, and if there's any error, unhandled error popping up in the error array, then I convert them to be written to the log file. This is the technical implementation of that. The next one is the termination. We may have errors so serious that we should not continue executing the script. So in this example, in line 79, let's imagine that there's a serious issue. Before this, can be a condition, and we want to exit from the script. You can see by this using this special type of entry, the type is terminate, it really terminated the whole script. You can't see any return or exit statement here, but the new entry function will terminate the script for you. So you can see that here's a special error type of entry called terminate in the log file, and we got the footer as before. So the logging module actually closed the log file for you. Let's continue. We can even terminate the execution from a function. So now the serious issue happened in the subfunction. You can see the context. You can see that it was a termination type and in line 23. So if I scroll up, you can see that here's the termination log entry written, and it really terminated the whole script. It not just exited from the function, but it actually terminated the whole script. So you don't need to bother with returning some special output value from the script, which is captured by the script, and then the script closes the log file and terminates itself. You can terminate the execution from anywhere. Okay, the next one is 05, the progress bar. As I mentioned, sometimes or quite often actually, my script contained a loop processing a lot of elements for significant amount of time. And of course, we are interactive, so we could see this progress bar on the screen. But in the meantime, the logging also generated a special entry type called progress. And I didn't want to run this loop for a long time, but the first entry was generated after, I don't know, let's check it. In line 112, you can see that the progress first log parameter says that it generated the first purple entry after 10 seconds. By default, it's actually 1 minute. And after this, every 5 minutes, it will generate a subsequent progress entry. And you can see that there is a statistics about how many elements were progressed, how many are left, and what is the estimated time left. So if there is a long-running script, you can even track the progress looking at the log file, and you will see an estimated end time of the loop. And you can see that this type of progress is quite easy to set up. Here in this comment, I put together the right progress statement. How many parameters it would require? It would require some text to be written. You need to calculate the percentages and so on. So it's quite complex to produce the correct progress bar. With my solution, you can see I only passed the array that I'm looping through. So you can see here is my for each loop. I'm looping through this array. And I just needed to show my write log process function, which is the array I'm looping through, and it will automatically calculate the percentages and everything. So basically, you just need to specify two parameters. The first is the array that you are looping through, and the second is the text that should be displayed in the progress bar. Of course, you can specify some more parameters if you want. You can override the percentages calculation if you want, and so on. But this is how it works. Okay, let's take a look at the next scenario. Outputting objects. You've already seen the call stack at the first scenario, but here I produce some very basic objects. You can see here the source code, object 1 and object 2. These contain some custom objects, and you can see that here I produce a list view of these objects. I can specify a switch parameter called divide, and in this case an extra divider line will be also inserted in the log file so that you can separate the objects easier. We can specify whether null values are included in the list or not. So here, even though I have an property name called empty, but you can't see that in the log file because it has a null value, and I specify that hide nulls. You also have the option to hide certain property values. In this case, I hide the secret property. You may have some objects containing password or some other sensitive information that you probably don't want to export to the log file. So you can hide these, and now you can see that in the log file, this sensitive information is hidden by these asterisk characters. And of course, we can output the objects in a table view as well. Here, I don't have this hide property function, but I rather use the exclude property option, and you can see that the table view is there. It's very similar to the format table. Okay, so this is exporting objects. The next scenario is when you have so many objects that it would mean not convenient to export them into the log file itself. You may want to use an external other file. And here you can see in line 145, I actually exported the data. In the ISE, you can see that the file itself is opened up. This is nothing fancy, it's just a standard CSV. It's not the real trick that I want to show you. But what I want to show you is how this CSV file is actually initialized. I use a function from my module called new log file. The log here is not the type of file I'm opening up, but it's the prefix of my logging capabilities within the module. So every function that starts with log belongs to the logging capabilities. So here I ask the module to open up a file called exportdata.csv. Actually, this won't be the exact name at the end, because you can see that by default, it will insert the date stamp into the file name. Of course, this means that if I run the script multiple times on the same day, then these CSVs will be overwritten. If you want to have a separate CSV for every time, then you can specify a switch called by seconds. Then in that case, the file will include not just the date, but the hour, minute, and seconds, resulting that a new file will be created every time you run the script. Okay, so I initialize this empty file, and then I will use the export CSV to export the information into that. And of course, if I run this script for years, this new log file will purge the old obsolete CSVs the same way as you could see the purging of obsolete log files at the beginning of my session. So here you can also specify how many days these files should be kept. By default, this is 60, if I remember well. And you can actually specify whether to override old ones and so on. So you have some additional parameters as well. The next scenario. Do you have any questions?
I had one about that. I think you answered it already. The kind of array data you allow in your progress commandlet, this can be any type of array, right? This can be number,
any type of array that has a count property.
Okay, I can throw, okay, I can't property, I see.
So it won't really use for any other purpose, just calculating the number of elements in it, and so that it can calculate the percentages. It will not touch the array at all.
Okay.
It will just read the size of it.
Mm-hmm.
Okay, so alternate log files, that's the next scenario. As I mentioned at the beginning of the session, I mentioned that one of the companies had this requirement to have alternate log files. So here we are. I run the script, and now you can see that the log file contains not just the date, but the hour, minute, and time, second digits as well. So if I look at the log, the folder, you can see that here's my current log file, the main one. This is the boring stuff, containing only initialization and some standard actions that probably will succeed majority of the times. And if I go back here in line 154, I initialized a new log file. So here's a new initialized logging statement. It has its own title. It has a custom name. I don't want to use the same name as the main log, but I want to have a custom one called item.log. And instead of having the default date, time, digits, I want to have a different content there. So if you imagine that the script processes some requested items from ServiceNow, for example, you want to preserve the log entries related to processing a certain requested item. Most probably, you would like to include the rhythm number in the related log file. So this is why I used this as an example. So this is another log file. And the next entry, new log entry, this is an entry in the alternate log file. I didn't need to specify any parameter that this entry should go to another log file, not the default one. It automatically switches to the latest log file. So I didn't need to specify a target where this log entry should go. It's all automatic. Of course, if you want to override this default behavior, the whole logging module maintains a logging variable, global variable, and in there you can see all the log files created and used during the PowerShell session. Of course, you can switch to another log file if you want. You can look up what other log files were used. So you have the option to switch. And in that case, with the new log entry, there's a log name optional parameter. And there, if I want to redirect my log entry to the main log file, I can just reference this log entry, this name, and then that specific entry will go to that file and not to the default one. Okay, so now my script is stopped. Where is it stopped? So it's stopped at line 182 because here's a wait debugger statement. So here we yeah, here I stopped. I opened up this ISE tab and I let it go. So I exited from the script. Here, I use this ignore log switch while exiting from the script. So if I go back to the logs folder and I refresh the screen, you can see that the default log with the date timestamp no longer here because it's automatically purged, but the item related log entries are log file is still here, and you can see that preserved. So this is how you can handle multiple log files very easily. Let's see. Module logging. This was one of the most challenging requirements. In one of the companies I worked with, the requirement was to have some custom modules. Here I created a dummy module. You can imagine that this module can be used by, for example, operations people. So for the day-to-day work, they can use certain functions from that module. For example, I use this get DM info, and here are some log entries written to the screen. So the requirement was that even if they have a module, that should do logging on its own. So without having a script invoking the functions of the module itself should do its own logging. So if I look at that logging variable, you can see that the dummy module itself has its special log file. So let's open it up. Invoke, $logging dot dummy module dot log folder. So I open up the log folder. It puts its log entries to the environment temp by default, and here's the dummy module log entries. You can see everything is logged. You could see that I didn't need to specify anything. So this get DM info didn't put its log entries to the log file of my script, but it intelligently put its own log entry into its own log file. So this is the trick. But if I
short interruption. Peter has to leave, unfortunately,
Mm-hmm.
and he's just asking around logging to emails. I think this will be covered.
In this version, there is no email capability. In the previous version of my logging module, I had this, but I rewrote the whole module at some point because it was such a patchwork that I decided to rewrite it from scratch so that it will be a clean, optimal code. But I can add this email capability anytime, so it's not a complex stuff.
Okay, thanks for the answer.
Actually, we have some email. Sorry, I misled you. I have already some sort of emailing capability. Initialize logging. If I look at that, I have the option to specify an SMTP server, and I also have an email notification address capability. So if you specify those, then the script will automatically email the log file when the script exits.
Okay, great.
But of course, you can override this, and you have the option to send specific emails at specific trigger events. So it's not full featured, but it has some basic capability to automatically email your log files. I think in case of errors and warnings, if there is nothing, it won't email it. But if there's anything unexpected, then it will email it to you. Okay. So I mentioned to you that now a module can have its own logging capability. You can see if I import this module, then this will be triggered. This initialization statement. It's a standard one. It has a title and it has a path. But if I import this module from my script, you can see in here, where is it? Yeah, while I'm importing my module, I pass the log name as an argument to this module. And in that case, this module will know that it should not create its own and use its own log file, but it should merge its log entries to the log file that was passed as a parameter. So this is how this module automatically switches between the different log files. So the next scenario is demonstrating that one. Here I outputting all the entries to the module. Sorry, to the script log. The problem is the following. In my main script, I defined a variable called $A. You can see here's the $A. When I invoke my subfunction, you can see this subfunction is inside the same script. And here's the log entry, that value of A, and it's really displayed here, variable defined in script. So because of the scoping of PowerShell, the parent scope, the variables defined in a parent scope are visible in a child scope. In this case, it's a function. So that's nothing new. But unfortunately, this visibility is not true for modules. So here I have my dummy module, and in the getDMInfo function in this line, you can see that log entry from my dummy module, value of A, and there is nothing. Unfortunately, this visibility is not working between a script and a module and the module function. So I have a slide for that. Sorry, here.
Just a timekeeping note, we have 3 minutes left in the official and the official time range.
Okay, so here's a chart. So everything is visible in this scope, but if we have a module, it's a separate scope. So it won't be able to see a variable. So this is why I use the call stack. So if we take a quick look, where is my PowerShell? If we take a quick look at the source code of the module, the script tools module, you will see that I'm using the get log name helper function, and the get log name is actually using the call stack heavily, and it reads the variable through the call stack. So when I'm doing this trick, alternate log files, where is it? I won't be able to find it quickly, but actually what I'm doing, I'm injecting the variable content to PS bound parameters. I'm doing a search for that quickly. You can see that here's the normal variable assignment, but I also inject the content of A into PS bound parameters, because through the call stack, I'm able to access the PS bound parameters of another scope. So the module is able to access the PS bound parameters of the script. And this is how I pass the information where a module function, in this case, this get DM info, should write its log entry true. So this is the trick. If you look at the source code, you will be able to see that I'm using the log name through the PS bound parameters, and I can access this through the call stack like that. So this was one of the most challenging issue that I needed to solve.
Module, right? I can imagine.
Yeah. So the next scenario is module logging with alternate log is just another variation of managing two log files, and the module is able to detect that now I'm switched to another log file. Simulate runbook, and this is the last one. This is when I'm running the script in Azure. I didn't want to set up an Azure environment, so I'm just simulating it. You can see that there are some log entries automatically put in the output or in different streams. So the warning is here, the error is here in its natural format, and in Azure portal, you will be able to see these during runtime. And I selected to have some log entries, info type of log entries, not all the infos, but the highlights and the progress ones to be automatically put in the output, so that you will be able to see the progress of your script in the Azure portal. But you can see only these. Why? Because you need to convert these log entries to be output stream, unfortunately, in Azure Runbook. And if you have a subfunction and it has some log entries, and if you convert them to be output, it probably will ruin the execution of the main script. So we can't do this in general. We can do that conversion only at the highest scope, so on the script level. But if I let the script finish, this is what I do. During exit, I read through the whole log file, and I convert each entry to be an output. And this is how you will be able to see all the log entries in the Azure portal. So this is why you don't really need to touch the script at all. You just need to use this module, and every log entry will be correctly handled in Azure. The script tools module will automatically detect that it's running in an Azure runbook environment.
Great.
Okay,
so
that was my demo.
I think I had about more than 10 moments in terms of what that makes total sense. I should have been thinking about that. So your 9 years of investment, I think, paid off. So can you maybe, if somebody wants to deal with it and maybe experiment, where should we start? What are the links to GitHub, or if somebody wants to test it, what's the best way?
Yeah, in the slide footer, you could see the GitHub link. So it's under my name.
Yeah.
And among the repositories, you will see the script tools. This is public. And I uploaded not just this, the module, but also you can see the slides. Not these specific slides, but the slides that I used in the PS conference. And you can also see the whole file set that I demoed to you. So if you investigate how this demo log PS1 is set up, how it invokes the module, the module functions, and so on, you will be able to understand the whole stuff, hopefully.
Great. I think there are people which said they want to test it, and people can reach out to you via email.
Yeah, of course. Feel free to reach out to me via email. I'm more than happy to help. So
yeah, external feedback often helps to improve what you can't see by yourself.
And as I mentioned at the beginning, there are some other capabilities in this module. So if you are interested in those as well, like the config management or property management, I'm happy to provide you a similar session if you want.
Okay. We'll think about that. So we have a little bit over time, but that doesn't matter. 5 minutes is okay, I think. And thank you very much, Tibor. Thanks for joining us, gentlemen. We will post the video, as always, on the Experts Live website, including the content and links to the GitHub repositories. And have a nice evening. Hope to see you soon at our next session in November. Yeah, and thank you and goodbye, everybody.
Thank you for the invitation.
It was good to have you here. Bye.
Bye-bye.
See you.